So in this video, I'm going to explain the fourth instruction of this arithmetic instruction group. So the instruction is ACI, add immediate to accumulator with carry. So the meaning of this statement is add the immediate content with the content of accumulator along with the status of the carry, and after performing the addition, this result will be stored into the accumulator itself, and as a result of this addition operation all the flags will be modified. So now we will see their opcode here. So the opcode of this instruction is here as a ACI, and as a operand how it has mentioned as a immediate data. So this will have here as a 8-bit data. The operand will be 8-bit data. So now we'll see their detailed operation with the example. So here let's say if I'm writing here that ACI 57H. So here before execution of this instruction, if we are taking here the content of accumulator as 26H and this data is here as a 57H and the status of carry we are taking here as a 1. So how we will perform the addition here? So this accumulator will have the content as 26H. So this can be written in binary as a 0010 then 0110. So this is 26H here, and now this data is given as a 57H. So this can be written 0101, that is 5 here, and as a 70111, and this carry status already we had considered as a 1 here. So this can be added at this position. Now we have to perform this addition. So from the first stage 0 plus 1 plus 1, sum will be 0 and carry will be 1, which can be added to the second stage. So at the second stage 1 plus 1 plus 1, so sum will be 1 and carry will be 1, which can be added to the next stage. So in third stage 1 plus 1 plus 1, so this sum will be 1 and carry also will be 1 here. So 1 plus 0, the result in this fourth stage as a sum will be 1 and carry will be 0. So in the next stage as a fifth stage 0 plus 1, sum will be 1 and carry will be 0. In the next stage 1 plus 0, sum will be 1, carry will be 0. In the seventh stage 0 plus 1, sum will be 1, carry will be 0, and as a last stage means 8th stage 0 plus 0, it will be 0 here. So we got the result here. This is 7 and this is here as a E. So this result will be stored into the accumulator as a 7EH. So now after performing this instruction execution, what will be the content here? So this accumulator content will become 7EH and data it will be as it is and carry will be modified as per the result obtained. So if you see here the result here, so this is here sign bit, this is 0, then this is auxiliary carry, this is parity bit, and this is carry bit here. So now if you see that this MSB is 0, so sign bit will be 0, result is non-zero, it means it is having 7EH, so this 0 flag will be also 0 here, and no carry generated from this position, so that is the reason auxiliary carry also will be 0, and number of ones if you count it here, it is here 6 in this result, so that is the reason this parity bit will be 1, it will perform here as a even parity, and there is no carry generated from this last stage, it means from the 8th position, so that is the reason this carry flag will be also 0 here. So what we can write it here? In the note we can write it here. So in the note we can write it here that as a result of this instruction execution, all flags are modified as per the result obtained after performing this addition operation. So it is very similar as like earlier instruction whatever we had seen as a ADI. So here the size will be again same as a 2 byte, because this 1 byte will be this opcode and another byte will be this 8 bit of data. So before execution of this instruction into the memory, it will occupy 2 memory locations. So that is the reason their size will be 2 here. And as a machine cycle also, as like in the ADI, here also it will be 2 machine cycle. So one is called opcode fetch. It means fetching the opcode corresponding to this ACI, and then the second machine cycle will be reading of this immediate data as a 57H from the memory. So for the execution of this instruction, this processor is accessing this memory chip 2 times. One is called as a opcode fetch operation and the second machine cycle is called as a memory read operation. So this can be written as a MR. So here for the opcode fetch, we know that by default it will take 4 T state, and for the memory read it will take 3 T state. So this will be 4 plus 3 total T states required. For the execution of this instruction will be 7 T states. So by this way you can compare this ACI along with the ADI, what is their similarity, what is their dissimilarity, and I hope you understand this instruction operation as well as the effect of this result, how it is going to change to the flags in the better way. So I hope you understand this instruction in much better way. Thank you.